So one ice age that is on the left, or many ice ages that is on the right, secular view. Again, different worldviews lead to different conclusions. Why? Because again, determining the past event in the distant past belongs to the historical science when assumptions are involved. This is because we cannot go back in time to visit when the specific event occurred. Make sense? Now let's examine the creationist model, okay, in greater detail here. Mike J. Ord is a creationist scientist whose research interests include geological evidence for Noah flood, the Ice Age, and the mass extinction of the woolly mammoths, and so on and so forth. And so he constructed a model of the Ice Age on the basis of what can be inferred from the Bible, combined with scientific evidence. So today's lecture on the Ice Age is based on his theory. But there are a couple of others, but they're kind of similar, okay? You have different technical background and a little different approaches, but basically they are saying the same thing, biblical Ice Age, basically. In the previous quiz, we learned that a glacier forms by the compaction and recrystallization of snow into ice. Okay, snow. Okay, now, this means that during the Ice Age, there must have been a lot of snowfalls, right? Okay, now, here is another quiz. What are the two primary conditions that are necessary for the start of an Ice Age? So this is a maybe tough question unless you already watched this previous videos from my lecture. So what are the two primary conditions that are necessary for the start of an Ice Age? In other words, what did trigger the Ice Age? Oh, okay, so Tunde put the low temperature, good. Now, question about here, low temperature. If you have low temperature, then basically, for snow, first you have to have a lot of evaporation from ocean, correct? Now, cold weather, or an entire Earth is frozen, then there's no evaporation. Where does water come from? So first condition is a lot of lots of evaporation. What is the first condition to get a lot of evaporation?
Other the sun for
Sun, okay. What
for
does sun do?
evaporation, like a high temperature.
Okay, high temperature. Okay, so how come the temperature is high here? So again, the hint is a huge amount of snowfalls. What is the condition to create a huge amount of snowfalls on the entire Earth? Okay, so sudden change of weather. Yeah, sudden change of weather. That's good. That's a good starting point. Now, what makes this sudden change of the weather? What? So we have good answers here. Lots of precipitation, yeah, and high temperature, yes. Sudden change of weather from high to low, something like that. Good. So that's not easy, right? So first, for the snow formation, number one, there must be evaporation of water from the ocean. So we need a warm ocean, number one. So we have to have a condition that makes warmer ocean. What is the other condition that is necessary for the start of an ice age? For the ice sheet formation, right? So warm ocean, you have a lot of evaporation. However, warmer ocean would not give any snow. It's going to give a lot of rain. For the ice sheet formation, snow accumulation, first you have to make it snow from rain, not rain, but the snow. Number two is snow accumulation should exceed snow melting. So that means what? It means that we need cooler summers than today. But the warm ocean and cool summers, it doesn't sound right? How come these two can go hand in hand? So that is a problem. Any idea? Put your thought here. What makes warmer ocean and cooler summers together? Because this is the necessary conditions for starting of the ice age. What will make this condition simultaneously? Turn on your video if you can. I'll turn on and off my video depending on the bandwidth. Okay. Thank you, guys. God sovereignty. Okay. Of course, God sovereignty. But here we can explain this through the scientific, understanding. Okay. Okay. So I think I have to explain here. Let's first start with the conditions to generate a warm ocean. Now, Noah's flood was a global catastrophic event, global and catastrophic event that dramatically changed the Earth's geology, biology, and climate. Scripture says that all the fountains of the great deep were broken up, and the windows of heaven were opened, and the rain was upon the earth 40 days and 40 nights. Okay. And Noah's flood was so massive here, so massive that the crust of the earth broken apart, and our planet's original supercontinent broke into several smaller continents as we see today during the flood. We talked about this last time. Last time? Last time. And last time. Now, the great cracks extended tens of thousands of miles, and hot magma spewed up through underwater volcanoes into the oceans through this process shown here. Do you see this left top? Okay. So these processes sort of lasted during the flood, this entire year, right? And this sort of produced so much heat that the average ocean temperatures could have climbed to over 30 degrees. Okay. So what happens then? Hot ocean water evaporates rapidly, forming intense storms, dropping heavy rains after the flood. Okay. We got the condition for heavy rain somehow here. Okay. But rains do not bring any ice age. A warm ocean alone doesn't produce heavy snow. All right. So what is missing here? What is missing here? Put your thought. Okay, I have a water cycle, and the deeper we go in the earth, the warmer it is. Crust is warm, it makes the warmer. Oh, okay. What's missing here? Ash in the atmosphere. Oh, you know something from there already. We need cooler summer, right? We need cool summer. However, with a warm ocean, how come we have cool summer, right? So, thing is, after Noah's flood, oops, too much. Thing is, after the Noah's flood, volcanic eruptions on the lands continue to occur globally. Continue to occur globally. So most of the particles spewed from the volcanoes can stay in the stratosphere for months to years. Even these days, it stays months for years for one big volcanic eruption. That blocks sunlight and causing the cooling effect over large areas of the Earth. So, for example, the year 1816 is known as the year without a summer because the summer temperature in Europe were the coldest on record. And this event was caused by the massive eruption of Mount Tambora in April 1815, Indonesia, I think. And during that period, fine particles spewed from volcanoes blocked sunlight and caused cooling of the northern hemisphere. So this is a scientific and historical fact. Now, the magnitude of volcanic eruptions can be estimated using the size of the area covered by volcanic ash ejected during a volcanic eruption. Mount St. Helen was a huge volcano that erupted in 1980. I talked about this Mount Helen before, right? And as you can see, after the eruption, 1/3 of the mountain disappeared. There was a huge eruption. Now, let's compare the size of St. Helen eruption with others by examining the area covered by tuff from the exploration. Tuff is a type of rock made of volcanic ash ejected from a vent during a volcanic eruption. So it was an enormous eruption, as you can see here, right? It was enormous. But there's evidence that in the distant past, it was a really distant past before probably even American Indians, settled down. there were much more massive eruptions in the North American continent. Of course, this event happened after all lands and mountains built, mountains and rivers or settled. Then you had this ash, but there's no record. So geologists found that there had been several gigantic volcanic eruptions in the distant past, one of which was 2,000 times greater in magnitude than the Mount St. Helens eruption. Huge, there was a huge eruption. Okay. So not only in the American continent, but all over the world, you have this record, geological evidence here. Okay, there's shreds of geological evidence of such gigantic eruptions. Can you imagine the scale? It's huge scale. Now, imagine that similar gigantic eruptions occurred globally right after Noah's flood. So that's during the Ice Age. Okay, at divergent plate boundaries as continents had broken apart. Okay, you have these gigantic eruptions at the boundaries as continents had broken apart. A lot of volcanic dust released into the atmosphere during those gigantic eruptions lasted for hundreds of years, not years, hundreds of years. During the peak of the Ice Age, that would have greatly shaded sunlight, which caused cooling of atmosphere of the globe for hundreds of years. It's totally possible. Now remember that the ocean temperature was still high right after Noah's flood, and during the brief period when the oceans were hot, right? During the cold atmosphere, because you have the hot, warmer ocean due to this underwater volcanoes globally, and then you have also volcanic eruption to air, right, through this at the edge of these boundaries. That was right after the Noah's flood because of this movement of the cluster and the mantle. Then you have huge volcanic ashes basically blocking sunlight for hundreds of years. So, however, the at the beginning, right, of the ice age, or right after the Noah's flood, actually the ocean temperature was still warm. But now the atmosphere becomes cooler, right, because of it blocking the sunlight. What happens here is during the brief period when the ocean were hot, due to the cold atmosphere in this, right, hot ocean and cold atmosphere, there were vast amount of evaporation from ocean, which would have caused near constant rain, global rain. It's not going to be harsh rain. It's gonna be just rain, like pouring water, very gentle, right? Unlike today's. But the ocean temperature would have continually dropped. Do you see this cursor? Continually drop here as evaporation from the ocean continues. So you look at this graph here, the ocean temperature continues to drop here, and also volcanic activity will be also dropping, like following the exponential curve here. Okay. So as it reaches critical ocean temperature, not the room temperature. I mean, I'm working on this room temperature type of work these days. Anyway, the critical ocean temperature about 200 years after the flood. So 200 years after the flood. So this is ice age, our estimation here. Heavy rain turned into heavy snowfall. So heavy rain up to this point, and then you return to snowfall when the condition becomes optimized for the snowfall. And then what happens here is the cold temperature and heavy snowfalls in the continents would have produced an ice age eventually here, beginning in polar regions and then rapidly extending over the continents and on the mountains. Make sense? Once the oceans cooled, now is the end of the ice age. Oceans cooled and the volcanoes become less active. The clouds thin now because the volcanic activity is slow, allowing more sun to heat the earth that will melt the ice sheet and glaciers. So that's the deglaciation period. So in summary, the high energy events during the Genesis flood were more than sufficient to cause an ice age. The ice age is rapidly explained. The ice age is readily explained by the climate consequences of the Genesis flood. There was only one ice age, not millions of ice ages. One ice age.